Alright, I want you to listen to me. This is the main function. This is where our program starts. What is this Tokyo main doing here? This tells the computer that this function, this main function from which everything begins, is an asynchronous function. That means it can send out and receive back information from the world, from the real world. Just read on what asynchronity is. Explaining it is out of the scope for this video. This right here, we will talk about later. This line defines a TCP listener. What is a TCP listener? TCP is a way for the computer to listen to information on one of the ports that are available on the computer. There are a lot of ports in the computer. I'm using port number 4221, and this just says that on this very computer, not anywhere else, on this very computer. So we start to listen to information on this port 4221 on this very computer. That's what this line does. We bind a listener to this port and then we start listening on it. Right here in this loop, we will be checking infinitely for all the incoming requests till the program doesn't end or we don't forcefully end it. Then, just in case there is a stream which has valid information in it, we will get this. We can get it here, and then if the stream doesn't throw an error, we can handle the connection by spawning a new thread. We're using Tokyo, which is the same Tokyo from here, which is helping us to run asynchronous functions in Rust. Rust doesn't natively support asynchronous functions, so we have to use Tokyo. Handle connection is the function that handles everything. All our logic goes into this function. Let's check out this function which receives the stream. Now this stream right here is a stream of bytes. It's a stream of UTF-8 characters. What? UTF-8 characters are characters which define a real character in the real world. This is where we handle the connection. It's an array of bytes, and bytes are how we identify the text in a computer. C might be the number 56 or something, and that's how we know. So this stream, if you look at it right now, is just a stream of numbers. Now let's see what we do with this stream of numbers. We create a new buffer, an empty buffer, and then we read the stream of numbers into this buffer. I know it's a weird way to write it, I get it, but what this is doing is just writing the stream of bytes into this buffer, and now all our bytes are in this buffer. Next, we can take the bytes from this buffer and turn them into characters, so we will get actual text from it, not just numbers, text. And then we can pass it into rec content. What is this? Rec content is this struct, but the question still remains, how does Rust know how to parse our strings into a struct? Well, we have to implement from string for rec content, and this is the code for it. It's pretty simple. It's just a bunch of if statements. This takes the first line, splits it into 3 parts. The first is the method, the second is the path, and the third is the HTTP version. Then we go to the rest of the lines, which are the headers, and we check for all the host headers and the user agent headers. And for the rest of them, we discard them. Doesn't matter to us because it is out of scope for this video. I'm just trying to explain a very basic concept in this. And then we return the struct, rec content, which is a rec content struct. We come back here, we get the struct right here. Then we create a new string. This is a heap allocated string, which we will be finally using to append our HTTP message to. These things. One of these will be conditionally appended to this text plain res. That's why it's a mutable variable. After this, we run a bunch of if statements based on, well, whether it's a path, whether it's an echo. This is just custom endpoints that I've written. This is all very custom. There's not the right way to do things. It's just what I've written. So don't worry if you feel like this is very foreign, because I just wrote it on a whim. That's it. And then in the end, you will notice stream write all, which means that it will respond to the client in bytes, and then the client will receive it and then print it out. Let's check it out. Now our server is listening. Let's send it a GET request at the echo endpoint. We've given it Kshitij here. This Kshitij went on to our endpoint right here. We got the last part of the endpoint, and then we added it to our res text right here. It goes here, and then it's written to the stream. After it's written to the stream, it ends up over here, right here. And that's how this works. Thank you for watching.